I was actually a bit scared about how big the room is, but I can't see anyone at all, so it's totally fine. Hi, everyone. Thank you for having me along to DevFest. It's really nice to be in Nantes. It's really beautiful. So yes, I have the pleasure of being here today to talk to you about animation, but particularly illustrative animation using SVG. So there's so much exciting animation stuff that you can do with SVG. Some properties are able to be animated, but shouldn't really be animated in production. So this should be a warning on my code pen, to be honest. So like animating properties of SVG filters. Oh, dear me. That should be working. All right, we'll try that again. Yeah, you can't have a talk about animation without things animating. That would be a no-no. So yeah, here I'm animating properties of SVG filters to kind of create this wobbly jellyfish effect. So this is actually a video of the code pen. If it was the actual code pen, my laptop fan would be heating up right now. So some of you might be thinking, why bother making a wobbly jellyfish in the first place if it's so non-performant? Right, okay. So I'm not going to pretend that it's all in pursuit of a higher purpose. I mostly like making cute things, like this jellyfish. But exploring animation and SVG on CodePen has also helped me understand more about web animation in general. It's helped me with interface animation, and it's helped me kind of dig into SVG and find out what it's capable of. It's also encouraged me to kind of play around with APIs and libraries that I might have otherwise passed by. So, right, let's start at the beginning. What is SVG? A lot of the clues in the name. So SVG stands for Scalable Vector Graphic. It's an image format that's scalable because it uses maths to plot and connect points rather than being made up out of pixels. So you can make SVG tiny or massive without affecting the resolution or file size. But SVG isn't just an image format. It's also a markup language. So once you get past the initial confusion of all of the ones and zeros, it starts looking quite familiar. It's got angled brackets and nested tags, just like HTML. In fact, it's a lot like HTML. So I really love how my friend Richard explains SVG. He says that SVG is basically an alternate universe version of HTML focused on graphics instead of documents. And just like HTML, SVG has a DOM. So unlike other image formats, which are kind of static, we can interact with elements inside an SVG and style them and move them around to make animations. So SVG graphics are basically illustrations that you can manipulate with code, which is super cool. So some of you might be thinking that you can style HTML to make animations too, which is a good point. You're right, we can. And in fact, some people make brilliant animations using HTML elements. So like this. Julia Muzafarova made this using divs and CSS, which is mind-blowing. But can you imagine how complicated it would be to work collaboratively on something like this? Imagine a designer that you work with handing you a mock-up and having to recreate it using divs and CSS. It would take a while. It's just not the right tool for the job. Sarah Drasner says that SVG is built for drawing in a way that HTML and CSS are not. So by creating artwork with HTML elements, you're kind of hacking things that are meant for layout. SVG acts as a common ground, and it allows for collaboration and seamless handovers between designers and developers. So the designer can create an illustration with SVG and then hand that SVG over to the developer to animate. So they can both contribute to the animation with different skill sets using the same file. And if you can design and code, if you're one of those lucky people, then you've got the entire process covered. The world of SVG is your playground. Basically, SVG is the best. But before I get too overexcited, we're going to take a trip back to 2001 and talk about how I got started making stuff on the web. So when I was 11, I'd wait until my parents were asleep, and then I'd quietly sneak downstairs to use the family computer. It was a really dangerous game to play because back then accessing the internet was really noisy. So if I managed to connect to the internet without waking up my parents, I'd log into Neopets. Who here had a Neopets account? Is there anyone? So Neopets was the best. If you weren't lucky enough to have a Neopet, I'm really sorry. But it was an online game, kind of similar to Pokemon or Tamagotchi. You could adopt little fantasy creatures like this and battle other people's Neopets and play games and trade goods on the Neopia stock market. The bit that was really exciting, though, was the customization that the game allowed. So Neopets didn't just allow us to customize our pages, they actively encouraged it. There was this super accessible, friendly HTML guide on the website that talked through everything that you needed to know in order to get started with coding. It's actually still live now. It's a little bit dated, though. It's still got marquee tags and blink and stuff. But at the time, this guide was brilliant. Young people everywhere learned how to code. And the guide also encouraged people to make custom background images. So we also learned a bit of design. I mean, if you can call Microsoft Paint design. So for me and many other youngsters kind of coming of age at the same time, this was our first introduction to these concepts. And I think that the sense of community and the knowledge sharing and the drive to create things was what drew me towards the web as a career. But front-end development has got very serious recently. We've come a really long way since the Neopets days. It's not all marquee tags and sparkly cursors anymore. And a constant stream of new devices and increasingly large and complex frameworks have come hand in hand with complicated build tools and JavaScript frameworks dominating job postings. Front-end seems to be ever expanding and kind of drifting further into the realm of computer science. There's a lot to learn nowadays. And without things like MySpace and Neopets, we've lost a lot of these original entry points for people into the field that are coming into the field non-traditional routes. And with the expansion of the field has come a bit of a division. So Chris Coyier wrote a really great article recently called The Great Divide. And he mentions a rift that seems to be opening up between people who identify as front-end developers, yet have divergent skill sets. I've heard it being referred to as the back of the front end and the front of the front end. And this divergence makes a lot of sense because front-end development is a perfect equilibrium between design and logic. The career appeals to a broad range of people who are both visual and logical, and whose skills and interests fall at different parts on this spectrum. And it's important to remember that people learn in different ways. So I organize and coach at a coding workshop called Code Bar Brighton. And we found that the more visual students can initially struggle with a more abstract approach to learning how to code. They learn best when they're making things, and coding concepts kind of click when they've got something visual or tangible to hold on to. And I find SVG is a really great starting point for visual people who are learning how to code. It provides this really excellent bridge between something tangible and the more abstract, and it works as a fun starting point to play around with other web technologies. So let's take DataViz, for instance. I don't know if anyone's had the pleasure of flicking through this book. It's really amazing. If you haven't, go check it out. And after reading this and looking at all the data viz examples in there, I thought I'd give it a go myself. So a JavaScript library that gets mentioned a lot for data viz is D3.js. But if you delve into the docs for a while, you'll realize it's got a pretty steep learning curve. Martin Birch says that the trouble with D3 is that to build a visualization, you must also have a deep understanding of SVG, DOM, JavaScript, geometry, color spaces, data structures, the standard model, and quantum physics. So it's a really amazing tool once you've got the grip on it, and you can do a lot with it, but there's quite a high barrier to entry. So for a lower barrier to entry, maybe before giving D3 a go, we can do data viz with SVG and plain JavaScript. So Robin Rendell has written a really great article on making charts with SVG. And he says making a chart with SVG can be as easy as designing one, exporting it as SVG, and then popping it straight into the markup. But why stop at charts? Data viz, after all, is all about telling a story, and a picture speaks 1,000 words. So at Clear Left, where I work, we had some solar panels installed on the roof. And these solar panels came with an API, which is exciting. So for Earth Day this year, I made a little illustration of our office and used it to show off our power savings. So we've saved 4.5 trees worth of CO2 emissions so far, and you can see them in our little virtual roof garden. And then the windows of the building also light up to show how much solar power we're using. So it's only at 33% because I live in England, and it's not very sunny there. So if you want to explore making your own SVG, there's a lot of graphics editors out there. I personally use Illustrator, but Adobe software is horrifically expensive and not accessible to everyone. So I asked the internet for some cheaper alternatives. Figma and Inkscape, they're both free, and they got a lot of love from people. And Sarah Swadan, who's the queen of SVG, recommends Inkscape as it generates good quality SVG code, which is arguably the most important thing. So if you can't spring for Illustrator, I'd go with her recommendation. And there's a lot of tutorials out there to help you get started with designing vector graphics. But if you're sitting here and you're going, I'm not creative, I don't like drawing, I don't want to make my own SVG illustrations from scratch, that's also okay. So you can download vector art online, and you can use that as a starting point. FreePic's a really great place to go to find SVGs to play around with. And you also get the added bonus of kind of getting to know SVG markup a little bit more by digging into how other illustrators have put together the SVGs. Right, so now you know how to get an SVG. Let's break down what you need to know to make a little animation. So we're going to animate this little Neopet. So a lot of the tricky bit with SVG animation is actually in the setup before you start doing the coding. SVGs are made up of different elements, and how these shapes are drawn will kind of dictate which bits we can animate. So like the body and legs have been drawn as one shape here, and because of that, we won't be able to animate them separately from the body. But the wings, they've been drawn separately, so they're unconnected from the shapes that make up the body, and we can move them around. So anything that I might target separately in an SVG, I arrange in its own layer or group down the side there. And the white box is the artboard. So once exported, an artboard becomes the SVG viewport. So an SVG viewport is kind of like a window into infinite SVG space. So it's the bit of the SVG that's visible. Anything outside of that box will be cut off, so you want to make sure that there's plenty of space around the view box so that the elements don't get cut off when you move them around. So I try and keep my layers nice and tidy and named logically. I don't always manage it, but most graphics editors will have an export option to save layer names to IDs. So if you keep your layer names nice and tidy, when you export it, you'll end up with nicely labeled SVG code, which can be pretty helpful as SVG code can be quite bloated and confusing. So once you've got your SVG, whether you made it or someone else made it, it's important to clean up the code before you start animating. The code that you get out of a graphics editor can be quite difficult to work with. And I really love SVG OMG for optimizing. It runs in your browser, and you can visually see the changes as you make them, so there's less chance of toggling something and getting rid of something important. And then once you've tidied up your code, CodePen is a really great place to start exploring SVG animations. So there's a really great community, and there's tons of examples to explore. And you don't have to faff about getting a project set up. You can just open up a pen, paste in your SVG markup, and get coding. Once you've got your SVG into CodePen, you might want to do a little bit more organizing of your layers and your groups. So if you want to target a particular bit of your SVG, and it's made up out of a collection of shapes and paths, it's a good idea to group them together and then animate the containing element. But it's really easy to get into a bit of a muddle here. SVG elements have an implicit drawing order, so Z-index doesn't work in SVG. So the shapes that are visually on the bottom of your SVG, like his wings, need to be at the top of the SVG code. Otherwise, that happens. Right, so animation time. CSS is a really great place to start. You don't need to add any libraries. The syntax is nice and declarative, and you can reuse keyframe blocks on multiple elements. But if you want to make something more complex, like that crazy example I showed you at the beginning of the talk, it starts getting a little bit messy. So with CSS, we can't chain animations one after another. We have to kind of fake chaining with delays. So if the first animation is 2 seconds long, we'll add a 2-second delay onto the second animation so that it starts when the first one ends. So that's pretty simple. But if we want to add a third animation, we have to add the duration of the first and the second animation to work out that delay, and then so on for every animation that you add on. And animations are never finished the first time. About 90% of the work that you'll put into an animation will be tweaking afterwards and tweaking the timings and easings once you've written the animation code out. So for a complex animation with lots of moving parts, this is a bit of a nightmare. If you want to change something or speed up the whole sequence, you might end up having to rewrite all of the timings. I have done this before in past jobs, which is why I learned that it was not the way to do it. Also, when it comes to SVG animation, there's a downside to using CSS. So transforms applied to SVG elements can behave differently in different browsers. And now this is particularly frustrating because transforms are so fundamental to animation on the web. They're how we move things around performantly. No one wants that. So the issue with transforms in SVG is down to how transform origin is actually implemented. So DOM elements measure transform origin from their own top left corner. But with SVG, in some browsers, transforms are measured from the SVG canvas itself. So there's a relatively new CSS property called transform box, and this looks really promising to fix this issue. But the browser compatibility isn't 100% yet. We don't have Edge or Internet Explorer. And transform box defines the layout box that the transform and transform origin properties relate to. So if the transform box is specified as fill box on an element inside an SVG, then the element's bounding box itself will be used as the reference box. And if it's specified as viewbox, the nearest SVG viewbox itself will be used as the reference box. So if you want to use CSS keyframes to animate an SVG and you don't mind writing out all the keyframes themselves, you can go this route, kind of the more progressive enhancement route. We can use feature queries to check if the browser supports transform box and then pop our animation code in there. If you do need to have that animation work in Internet Explorer and Edge, and your animation is too complex to write out all the CSS keyframes, then it's probably time to reach for a JavaScript animation library. So there's a lot of JavaScript animation libraries out there, but these three are some of the more multi-featured and most popular. So these libraries all handle SVG transforms cross-browser, which is excellent. GreenSock and Anime give you the ability to organize your animations using timelines. And timelines make chaining and sequencing animations a lot easier. Velocity uses sequences and doesn't have a native timeline. So I find this a little bit harder to work with. Anime is the most lightweight at the time of writing this. GreenSock was the heftiest. It also was modular, so you could pick and choose the bits that you needed to cut down on file size. But, excitingly, GreenSock have just announced a new release, and that's coming out next week. So V3 is going to see the file size cut in half, and the API simplified, as well as some pretty exciting new releases as well. I don't know how they've managed to add more stuff and make it smaller, but they have. It's magic. So licensing-wise, Anime and Velocity are both MIT licensed, so you can do whatever you want for free. And the GreenSock licensing model is sometimes a little bit misunderstood. All of their core features are open source and free to use on whatever you want to use them on. But you do need a license if you're selling a product to multiple end users, and some of their plugins are behind a membership fee. But I think one of the most important things is to be able to get help when you're stuck. All of these libraries have really great documentation and really good examples on CodePen, but GreenSock also has forums. And the forums are really active, and they're full of people that are really ready to lend a hand and help out. So when it comes to choosing one, as always, it depends. So I think you should weigh up your options and choose on a project-by-project basis. The core concepts behind them all are the same, though. So if you do learn one, it's not like you've wasted your time. It will be applicable over all of them. It's just kind of the syntax that differs. So I tend to use GreenSock the most, mainly because of their forums, and they've also got a bunch of SVG-specific plugins, which are a lot of fun. So now I mentioned the membership fee for some of the plugins, but all of them are free on CodePen, so you can just go crazy. You can use whatever you want, which is great for making demos and stuff. So there's a few that are made specifically for SVG. There's Draw SVG plugin. That allows you to progressively hide and show SVG paths. Now, that doesn't look very exciting, but this is the kind of thing that you can achieve with Draw SVG. So it wouldn't be an SVG animation talk without an example from Chris Gannon. This example was actually originally done by Salih Abdul Karim from Airbnb, and he was using Body Moving, which is an After Effects plugin that lets you export animations out from After Effects to HTML and JavaScript, SVG, and Canvas. But Chris remade it just using SVG and GreenSock to kind of prove a point that inline SVG animations can be just as flexible as After Effects animation. It was a lot smaller as well, file size-wise. If you ever want to morph a circle into a hippo, there's also Morph SVG plugin. So that makes morphing between different SVG paths a breeze. If you've ever tried to morph between SVG paths manually, you know how tricky this is. If your path doesn't have exactly the same number of points as the other path you're morphing into, it all goes horribly wrong. So Morph SVG deals with a lot of this complicated maths behind the scenes, so you don't have to. Right, so nobody take photos of this. This is actually secret. This is a super secret sneak peek at one of the plugins in v3 GreenSock. So Motion Path plugin lets you turn SVG paths into a motion path to animate objects along. But they've also got this motion path helper, so you can actually edit the path in the browser and move it around. It's really handy because a lot of the time, if you're animating with motion paths, you'll be jumping backwards and forwards between Illustrator, drawing the path, putting it into your SVG, it's not quite right, back to Illustrator, draw the path, and now you can just do it all in the browser. It cuts out that step entirely. It's really handy. So yeah, all the cool features of GreenSock definitely warrant their own talk, but we don't have time for that. So we're just going to focus on the need-to-knows for now, and then get our little Neopet animated. So before you get started, you'll need to add the GreenSock library to your project. And once you've got that sorted, you're ready to start tweening. This is where everyone goes, what's tweening? So good question. I'm so glad that you asked. So tweening is short for in-betweening. A tween is the name for a single movement in animation. So this could be a movement in space from point A to point B. Or it could be a movement in state from one color to another. So the ease that you choose is what determines the timing and the spacing of the in-between frames. So things in the real world don't just move consistently from one place to another, unless they're in space and don't have gravity to contend with. So easing is what brings your animation to life and makes it feel more like it's got a bit of personality. So we're a little limited with easing in CSS. We've got animation timing function. We can put cubic Beziers in there, but we don't really have much to manipulate. Whereas GreenSock provides a lot more easing equations than we get with CSS. So we can make a lot more interesting and realistic animations. That rough ease is actually amazing. I've made loads of glitchy animations where all I'm doing is animating something from one place to another, but the ease itself makes it jerk around. It does all the heavy lifting for you. So you can create some really interesting effects quite simply. So in GreenSock, a tween looks like this. There's a whole bunch of GreenSock methods, but most of the time you'll be choosing whether to animate to or from some values. You'll choose what you want to animate and how long you want to animate it for, and then what values you want to change. So you can create individual tweens like this, or you can take these tweens and then you can sequence them together on a timeline. So timelines kind of act like a container that you can place tweens in, or even other timelines in, so you can get a bit Inception with it. And timelines keep all of your tweens organized and give you a lot more precise control over the animation as a whole. Timelines themselves also have a bunch of different methods that you can call if you want to speed up the whole sequence or reverse it or pause it. And these are really handy to kind of tie into events, like maybe scroll events or like click events and stuff. Also, GreenSock also has dev tools. So you can add a neat little timeline scrubber like this, and then you can debug your animation a lot easier. But yeah, let's take a step back from the tools for a second. So the best thing about web animation isn't to do with the developer experience or the specific tools that we use. It's to do with the user experience. So when you animate on the web, other people can interact with your animation. So this adorable example is from Catherine Cato. And being able to factor in external interaction brings a level of playfulness and fun and creativity that you don't get with traditional methods of animation. And we don't have to just stop with hover effects. We've got all sorts of cool stuff that we can play with in the browser. So like the Web Audio API. So speaking of which, I've made our little Neopet interactive. So this isn't at all a cheap gimmick to make it sound like you're enjoying my talk, but the more you cheer him on, the happier he gets. So are you ready? You have to give him a big cheer. More tech issues, wait. Oh. Okay, give him a cheer. Louder! Yay! Woo! Oh, that's so much fun. And we can also play around with interaction from a webcam. So this little chameleon I made changes color when you hold different objects up to the webcam. So under the hood, I'm getting the average color from the feed, and then I'm updating some CSS variables. So it's a lot of fun, but it can be a little bit tricky working with pixel data. I learned something that will definitely help if you want to give it a go. So when you're working with pixel data from a webcam, in order to get the data from a webcam feed, we draw the webcam feed to a canvas, and then we can sample the underlying pixel data. But the array of pixel data that you get back is massive. There are a ton of pixels to sift through. We're talking near 1 million color values. But what we can do is we can change the canvas dimensions. So you can draw the image frames to a smaller canvas, for example, 4 by 4 pixels. And then you can also visualize that in CSS with image rendering pixelated, which I didn't know existed, but that's really cool. And then if you want to get an average color, this is a much more manageable number of pixels to be working through. You can do that pretty simply. I've linked to this code pen as well in case you want to dig into it, because it's quite a lot of code to go through. I don't want to put up a big wall of code. And color detection is not the only thing that we can explore with webcam. So machine learning and things like face detection are becoming more common and more accessible. There's a lot of face detection libraries out there. I've used Face API before, which is built on top of TensorFlow, and that's great. But did you know that you can also do face detection in the browser? Whoa. So face detection is quite computationally expensive, and that's been a downside to a lot of the libraries in the past. But mobile manufacturers have been supporting it for a while using hardware-accelerated detectors. And Chrome's shape detection API exposes these for us to use. So it's technically not out yet, but it's available behind a flag in Chrome. So if you paste this address into your browser, you can enable it and then give it a go and also give the Chrome team feedback. So yeah, don't worry too much about the code. I've linked it in a code pen in case you want to dig into it a bit later. But in order to give the face detector a webcam feed it can analyze, you first have to get the webcam feed and then stream it to a video or HTML canvas element. So once you have your feed and you've created a face detector, then you can call the detect method to look for faces. You can also detect faces in images or in normal videos, but it's not as much fun. So it's really, really accurate. When I was first trying it out, I was convinced it was broken because I kept moving out of the way of my camera, and it was still seeing a face, even though I was out of frame. But eventually I realized that it was picking up a face on a poster on the wall right behind me. So it sees just the smallest faces. It's crazy. It doesn't work on dogs. I tried it. Even if they're cleverly disguised as human, doesn't work. But when you give it actual human faces, you get back an object for every face that it finds. So each face object has a bounding box showing the position of the face. And then it also has an array of landmark objects for your features. Now, I'm not going to pretend that face detection is all fun and games. A lot of the use cases are quite morally contentious. But we mustn't forget to have fun with new technology too. So in a world that's getting increasingly dystopian by the day, why not use our power for good? So we can use technology to inspire or educate or just to make people smile. This little blob gets shy when you watch him dance, and he stops dancing. I made it for a workshop with some kids. But then I put it on Twitter, and a whole bunch of adults also really liked it. And seeing as it's interactive, other people can play with it. So I really love that I managed to get a bunch of grown-ups to take time out of their day. A lot of these people are programmers. They've got serious jobs. And they stopped and they played peekaboo with an SVG. So to wrap this up, what I love the most about SVG animation is how it provides a link from the world of design to the world of development. And I still find it amazing that I can create something in Illustrator, pop it into a web page, and then use code to bring it to life. So yes, front-end may have come a long way since the days of Neopets, and the amount of stuff out there to learn may feel intimidating sometimes. But we have more technology to experiment with nowadays. We don't have to rely on marquee or blink tags or GIFs for animation anymore. We have SVG and GreenSock and ways to create interaction right there in the browser. A lot of us here got into careers on the web because we want to make stuff, because we enjoy creating and we like tinkering. And it can be easy to lose sight of this in the race to keep up and learn the latest things. So if you've related to this at all, make sure that you don't lose sight of this motivation. Keep making fun stuff. And if you do, I'd really love to see it. Thank you.